Before we approach site interpolation, we need to understand the formula. What's the formula? It's small d divided by capital D equals small e divided by capital E. To understand this, we need to draw a diagram. So let's say we have these four grid points, and between these grid points we have 25.5, 27.5. These are all elevation points, 29.5 and 28.5. Just say. So these are the elevation points of the grid. Now the elevation difference between two grid points would be this. So for, say, line A, E would be 27.5 minus 25.5, which is 2. So that would be the big E, the elevation difference between two grid points. I'll write that down. Elevation difference between grid points. It's common sense. The big D would be the horizontal difference between the grid points. So if this was, say, 100 feet, D would be 100 feet. So big D is the horizontal difference between grid points. Now the question is, what are small d and small e? So let's say we need to find a contour line or an elevation point of 25 feet. Or no, we can't, 25 feet cannot be here. Let's say we want to find 27 feet. So 27 feet would be the intermediate elevation point between 25.5 and 27.5. So if we are calculating from 25.5, small d would be 27 feet minus 25.5 feet, which is 1.5, which is the elevation difference between the intermediate point and the grid point. Okay, so that would be small e, elevation difference between intermediate point and contour point. Okay, and usually we have to calculate for d. D is the horizontal difference between the intermediate point and the grid point. So if we were calculating this for this point, we'd get a horizontal difference between this. Now this is extremely important because sometimes we might calculate one, but we'd get, like, we'd write down that the elevation difference is from here to here. So that would be a mistake because this and this can mean very different things. So whenever we are trying to calculate the small d, we need to understand which point are we calculating from. If we were getting the d for this point, then our d would be this. Instead, if we were calculating from 27.5 minus 27, which is 0.5, our calculated d would be this. So don't mistake one for the another and keep one grammar across your calculation. So that's the formula. Small d by capital D equals small e by capital E, where we usually have to calculate for small d. We have capital D and capital E usually given, and we usually can get small e just by subtracting one elevation from another. So that's the formula. Now there are 4 steps to interpolate a contour. The very first step is to observe. So here let's think about this question for a second. Draw 1-foot contours that result from interpolating between the elevations provided. So what are my elevations provided in this image? We have a 95.3, we have a 96.9, 97.3, and 98.5. So this is our smallest value in terms of elevation point. These are all elevation points of this grid specifically. So this is the smallest elevation point. One full contour point cannot go below this. So we can't have, say, a 95-foot contour line. The lowest we can have is 96, which is kind of above this. So the lowest we are going to have is 96 feet. And what's the highest we can get? So from this image, we can see that there's a 98.5, so we can't go above. So we can't have a 99, for example. So the highest we can have is a 98 foot. So this would be our 1-foot contour line. So between 96 to 98, so those are 96 feet, 97 feet, and 98 feet. This is the first observation we are making, that we are gonna have these 3 contour lines. Now the next observation we need to make is where the elevation points can be. So let's take a look at this. Let's try to find 96 feet elevation points. So 95 feet and 96.9 feet. So it's going uphill, and somewhere in the middle, or maybe somewhere within this line, we can have 96 feet. Let's say this is where our 96 feet might be. So that's another observation. Can a 97 feet be anywhere over here? Answer is no, because the highest point that we have is 96.9, which is below 97 feet, so we can't have a 97 over here. So what about this? So 95.3 and 97.3. So yes, a 96 feet can be somewhere over here, because a 95 is below 96, 97 is below over 96. So a 96 can be somewhere over here. And what about 97? Can a 97 be here? The answer is also yes, because 96 and 97.3. So a 97 can be somewhere over here. So note that we're trying to make an observation. We're trying to understand on which line full elevation points can be. These are not drawn on scale, that would come later. So what about this line? Can a 97 feet line be over here? The answer is no, because the lowest point is 97.3 and it only goes uphill. So a 97 feet can't be anywhere over here. What about this guy? 96.9, 98.5. So yes, a 97 can be somewhere over here. Now, what about 98? Can a 98 be over here? No, both of them are below 98, so a 98 can't be here. Can a 98 be over here? The answer is yes, a 98 can and will be somewhere over here. Can a 98 be over here? The answer is yes, a 98 can be over here. So our approximation of contour lines would look something like so. So this is an approximation. This is not accurate. We are going to make it accurate through our calculation, which is the next step. So now it's time for calculation. Let's name these lines for our convenience. So line A, line B, line C, and line D. Let's start our calculation. We have to remember the formula that we just learned. Small d by capital D equals small e by capital E. So let's start for A. So for A, what we can see is our elevation difference between grid points is 96.9 minus 95.3, which is 1.6. Great. What about D? Big D. Big D is 25 feet. That's already given. What about small e? Small e is gonna be 96 feet minus 95.3 feet. Also, it could be 96.9 minus 96, but I usually keep my calculation from small to larger. So the dimension I will get is going to be this. Instead, if it was 96.9 minus 96, that dimension would be somewhere over here, but we're not doing that. We're going to do this. But you can do that, but just keep one consistent grammar all through. So this is going to be 0.7 feet or 0.7 feet. Now let's put it to the formula. The formula is d by d equals e by e. Therefore, d equals e by e into capital D, which is 0.7 divided by 1.6 into 25. Let's do the calculation. So 0.7 divided by, sorry, my bad, 0.7 divided by 1.6 into 25, which is 10.93. Great. So this dimension right here is 10.73 feet. All right. So let's do it for B. B has 97 and 98. So let's find the E. E is going to be 98.5 minus 96.9. 98.5 minus 96.9. It is 1.6. Big D is going to be 25 feet. This is the grid distance. Small e are going to be different for 97 and 98. So let's do it here. So for 97 feet, small e is going to be 97 minus 96.9, which is 0.1 feet. So in this case, small d, we are going to use this formula directly instead of this now, is equal to e by e into d. This is 0.1 divided by 1.6 into 25. So this is 0.1 divided by 1.6 into 25. So this is 1.56. And for 98 feet, because we also have the 98 feet over here, so for 98 feet, small e is gonna be 98 minus 96.9. 98 minus 96.9, which is 1.1 feet. So D equals E by E into D. 1.1 divided by 1.6 into 25. Let's do the calculation. 1.1 divided by 1.6 into 25. So 17.18. So we have two dimensions, as we can see. One is 1.56. Both are going to be from this guy. So this right here is going to be 1.56. And this right here is going to be 17.18. Now let's do for D, because D also have two. So for D, and this is for line D. Our E is gonna be 97.3 minus 95.3, which is 2. Our D is gonna be 25 because D is consistent all through. Our small e are gonna be different. So let's do it for 96. E is gonna be 96 minus 95.3. And also we need to do for 97. E is equal to 97 minus 95.3. Let's calculate. That's gonna be 0.7. That's gonna be 1.7. So small d equals E by E into capital D. 0.7 divided by 2 into capital D is 25. So 25 divided by 2 into 0.7. This is 8.75. So 8.75 is from here to here. Now let's do for 97. D equals E by E into D, which is 1.7 divided by 2 into 25. So let's just do it 1.7, so 21.25. This is gonna be 21.25. Now for the last bit, for line C, line C only have one elevation point, which is 98 feet. So our E is gonna be 98.5 minus 97.3. .2. D is again going to be 25. Small e, I always calculate from small to large. So 98 minus 97.3, which is 0.7. So for D, E by E equals into D. So that equals 0.7 divided by 1.2 into 25. So 0.7 divided by 1.2 into 25. That is 14.58. So 14.58 is from this to this. Okay, so now we have it. So that is the calculation part. Now is to place them in a scale and connect. So stage 3 and 4. So let's do that. So we have a rough drawing, but now we need to place them in a scale. So I'll use this triangular scale. This drawing was done in a scale of 1/4 inch equals 1 feet. So we need to find that scale. Let's see, where is that? 1/4 here. This is the 1/4. This is the 1/4. So now we need to find a 10.73 here. So let's see. So 10 is right over here, and that is 11. So 10.73 is going to be something like this. So that is at 96 feet. There's another one at 8.75 in this. So let's try to find that. So that is 9, that is 8.75. Great. So this line is gonna be our 26 feet contour line. Okay, now we need to find the 97. 97 is here, 1.56. Let's see if we can place this. We are trying to find 1/4, which is here. So that was again 1.56. So we need to find 1.56. So 1.5, a little more, 1.56. And another one is gonna be at 21.25. So let's try to find that. 21.25. So 18, 19, 21.25. So that is gonna be our 97. Now for 98, we have 17.18. So that is 0. We need to find 17, 8. So that is 17.1, a little more. And then we are gonna do 14.58, which is here. So 14.58. So this is 14 and this is 14.5, 14.58. So 98 feet is gonna be something like this. So this is our step 4 and step 5, step 3 and step 4. Placing it in a scale and then connecting the dots to get our contour lines. So that's the basic of the formula's steps and how you can approach contour line interpolation. Before we do anything, it's important to understand what the task is. So here the task is draw 1 feet contour line that result from interpolating between the elevations provided. So these are a set of grid points that is given to us, and we need to interpolate the contour lines. So before we do anything, we need to kind of connect these lines into a grid line instead of them only being grid points. So let's do that first. Okay, now that we are done with the line drawings, let's give these lines some name. Let's say this is our line A, this is line B, C, D, E, F, G. Sorry, F and G could be over here. So F, G, H, I, J, K, and L. Great. Now the first point or the first step in this task is to observe what's given and try to find out the elevation points for 1 feet contour lines. To do that, we need to determine what's the lowest point that can be here in terms of full 1 foot and what's the highest point. So if we look closely, we'll see that 24.27 is the lowest contour point over here. So nothing can go below that. So in terms of a full 1 foot contour line, a 24 cannot happen. It can only go above 24.27. So the lowest point that we can have is a 25 feet contour line. Okay, and same for the highest. So if we look again, the highest is here, 30.75. So nothing can go above that. So we can't have a 31. So the highest we can have is 30 feet. So we're looking for contour lines between 25 feet to 30 feet. So 25 feet contour, 26 feet contour, 7, 8, 9, and then 30 feet. So let's take a look. So let's say we're trying to find a 25 feet contour line. Can it be can 125 feet contour point be on top of line A? Let's see. So we can see the lowest is 25.5 feet and the highest is 26.8 feet. So there's no room for 25 feet because it's only going uphill, 25.5 to 26.8. So both of them have a value above 25 feet. So a 25 feet point cannot be here. Same for line B, 26.8 feet and 28 feet. So both of them are above 25 feet. So a 25 feet contour point or a 25 feet elevation point cannot be here. What about C? This is an interesting case because the lowest here is 24.27, whereas the highest here is 25.5. So 24.27 and 25.5. So yes, 24.27 is below 25. So a 25 feet contour or a 25 feet elevation point can be somewhere over here. So that's settled. Now, what about line F? 24.27, 28.85. So yes, we can say a 25 feet point can be somewhere over here. What about H? 24.27, 30.75. So definitely a 25 feet can be somewhere over here, 25 feet point. What else? Let's see. In the case of D, 26.8, 28.85. So no. In the case of I, 28.85, 29.5, both of them above 25 feet. So no. 30.75, 29.5. So no. 29.5, 30.75. So no. 28, 29.95. No. 29.95, 30.75. So no. So the only three 25 feet contour elevation points that can be in our grid lines are this, this, and this. So one is on top of C, one is on top of F, one is on top of H. So if we connect the three of them, we'll have a contour line of this. Now, what we are doing is an approximation. We'll come back and use this scale to draw them accurately after we are done with the calculation. But at this point, we're just trying to visualize what it might look like. Big emphasis on might. So we're done with 25 feet. Let's talk about 26. For a 25.5 is below 26, 26.8 is above 26. So somewhere over here, we can say we can have a 26 feet line. 26.8 feet 26.8 feet and 28 feet. So no, we can't have a 26 feet over here. 25.5 and 24.27. So no, both of them are below 26 feet. 24.27 and 28.85. So yes, a 26 can be somewhere over here. 24.27, 30.75. So yes, a 26 feet can be over here. 28.85, 29.95. So no. 28.85, 29.5. No. 29.5, 30.75. So no. So 26 feet contour line would be something like this. Again, something like this. This is not the exact contour line. We are approximating. We don't know the positions of this yet, but we are just determining that yes, they can be on these lines. All right, 27 feet. For 27 feet, 25.5, 26.8. So no, both of them are below 27 feet. 26.8, 28. So yes, maybe some over here is the 27 feet. 26.8 feet, 28.85 feet. So yes, 27 feet can be somewhere over here. 24.27, 28.85. So yes, 27 can be somewhere over here. 24.27, 30.75. So yes, 27 can be somewhere over here. 28.85, 29.5. No, both of them are above 27 feet. 30.75, 29.5. No, they're above 27. Both of them are above 27, above 27. So no. So the 27 feet contour line would look something like this. All right. So 28 feet, we already have a 28 feet, so we don't need to kind of determine in between these lines. There's one 28 feet already given. For line D, 26.8 and 28.85. So yes, somewhere over here can be a 28 feet contour line. What about this guy? 29.5 and 28.85. So no. What about this? 24.27, 30.75. So yes, 28 feet can be somewhere over here. And for the rest, we can say no. So our 28 feet contour line would look something like this. Awesome. Now 29 feet. 29 feet can't be here, can't be here. Both, all of them are below 29 feet. It can be somewhere over here though, because this is 29.95. It's 28. So yes, somewhere in between lies 29 feet. 28.85, 29.95. Yes, 29 feet can be somewhere over here. 28.85, 29.5. So yes, 29 can be somewhere over here. 30.75, 29.5. So no, both of them are above 29 feet. 30.75, 24.27, yes. 29 can be somewhere over here. 29.5, 30.75, so no. 29.95, 30.75, no. So our 29 feet contour line would look maybe something like this. Great. Now for the last 30 feet contour line, there cannot be any 30 feet here. Both of them are below. There can't be any. There can be one over here because 29.95 and 30.75. So yes, somewhere in between would be the 30 feet contour line. 28.85, 29.95. So no, there cannot be any 30 feet contour line over contour point over here. 29.5, 30.75. So yes, and 30.75, 29.5. So yes. And I think that's it. So our 30 feet would look maybe something like this. Oh, one more, 30.75 and 24.27. So yes, somewhere over here I also have one more. So this is what our contour map would look like. Okay, we have a contour line for all of the contour lines between 25 feet to 30 feet. Now it's time for our calculation. Now that we have determined what can be where, let's start with the calculation. Let's start for 25 feet. So in the case of line C, we will try to apply the formula that we have learned so far, which is d divided by capital D is small e divided by capital E, where this is the horizontal distance, ultimate horizontal distance between the grid point, the capital D. The small d is the immediate horizontal distance. Small e is immediate elevation difference, and capital E is the overall elevation difference between two grid points. Now, if we look at line C, in the case of line C, we will see that the elevation difference between the grid points are 24.27 minus 25.5, or 25.5 minus 24.27. So the capital E would be 25.5 minus 24.27, which is 1.23 feet. Now, what's the small e? What's the immediate elevation difference? That would be 25 feet minus 24.27. We're calculating from this to this. So whatever distance we're going to get is coming from this. This would be our overall small d, not this. These and these are very different. So we are calculating from small to large. So small e is going to be 25 feet minus 24.27 feet. So 25 minus 24.27 0.73. Great. We already have a capital D, which is 18.75. It's given to us. We don't have the small d, which is the distance between this grid point and our 25 feet elevation point. So we're trying to determine this, which is small d. So the calculation for that would be d by d equals e by e. Therefore, d equals e divided by capital E into capital D, which is, let's put all the values, and we are going to use this value over this equation over and over again. We are not going to change all these because in all of our cases we are going to determine the small d. So small e is 0.73, capital D is 18.75, and capital E is 1.23. So let's determine that. So that is 11.12 or 11.13. So this distance is again from this point to this, not this to this. They will be very different. So we can say that 25 feet elevation point is going to be at the distance of 11.13 feet. So let's try to determine for this, and we will do it for all the lines. So from now on, I'll try to streamline the work process and try to determine all the elevation points that are on a line. So let's do it for line B because there's only one. So we'll go serially, A, B, C, D, and things like those. So let's do it for A. We did not go serially. That's my fault. So for line A, we only have 26 feet. So let's determine all of these guys. So capital E is 25.5 minus, sorry, 26.8 minus 25.5, 26.8 minus 25.5, which is 1.3. So small e is gonna be 26 minus 25.5, which is 0.5 feet, and capital D is 25 feet. So for D, small d equals this. We are using this equation directly now. So that would be 0.5 divided by 1.3 into 25, 9.61. So that distance is from here. So from here to 26, the distance is gonna be 9.61 feet. Great. Now let's do for B. On line B, we only have 27 feet, nothing else. So let's do it for line B. D, capital D is gonna be the same. Capital E is gonna be 28 feet minus 26.8. Okay. 1.2. Small e is gonna be 27 minus 26.8. 0.2. So D equals E by E into capital D. 0.2 divided by 1.2 into 25. That is 4.16 or 4.17. So 4.17 is gonna be from this to this. Great. Now we already have done for C. Let's do it for D. We have our capital D is gonna be 18.75. Capital E is gonna be 28.85 minus 26.8. 2.05. And for E, so now we have two elevation points on top of D. So we'll create two small e's. So E27 and E28. So let's do it here for 27 feet. E equals 27 minus 26.8, which is 0.2. And for 28 feet, underline E, small e would be 28 minus 26.8, which would be 1.2. So now let's calculate. D is equal to E by E into capital D. That is 0.2 divided by 0.2 divided by capital E is 2.05 into capital D 18.75. So that would be 1.82 feet. So that would be from here to here. So definitely this is not in scale. This was a very rough approximation. So from here to here, the dimension would be 1.2 feet. Now let's do 1.82 feet. Let's do for 28 feet. D equals E by E into D, which is 1.2 divided by 2.05 into 18.75. So let's do the calculation. 1.2 divided 0.2 divided by 2.05 into 18.75, 10.97. So from here to here, this would be 10.97. Awesome. Now let's do for E, only one for E. So D is gonna be 18.75, capital D. Capital E is gonna be 29.95 minus 28. 29.95 minus 28, which is 1.95 feet. And small e is gonna be 29 minus 28, which is 1. So D equals E divided by capital E into capital D, which is 1 divided by 1.95 into 18.75. .61 or 9.62. So that is from 28 to 29, from here to here. If I would have done the difference in a separate way, say I would have done it from 29.95 minus 29, then the dimension would be somewhere over here. But as we are doing from small to large, our small d is going to be this guy. So 9.62. Great. Now let's do for F. We have a lot to do in F. So for line F, we have 25, 26, 27, and also 28 somewhere. So let's do all of those. Let's do the common stuff first. So in our case, we have the capital D, that is 25 feet. We have a capital E, which is 28.85 minus 24.27. 28.85 minus 24.27. Let's do that. 4.58. And we will determine D and E's as we go along. So let's write it down. So we have a 25 feet small e is going to be from here to here. So 25 feet minus 24.27 feet. 25 minus 24.27, 0.73. So we'll do the calculation later, but let's determine all the small e's first. For 26 feet, for 27 feet, for 28 feet. So for 26, E is gonna be 26 minus 24.27, which is 1.73. For 27 feet minus 24.27, this is 2.73. And for 28, 24.27 feet, this is 3.73 feet. So now that's done, we can very easily calculate D. All right, we have these dimensions. Now for G, we only have one, so that would be pretty simple. Our big D is 25 feet. Our small e is 29.95 minus 28.85. .1, and this is our big E, and our small e is 29 minus 28.85, which is 0.15. So let's do the calculation. Sorry, my bad. E divided by capital E into capital D. So that is 0.15 divided by 1.1 into 25. 0.1 divided by 1.1 into 25. So that is, my bad, 0.15 into 1. Divided by 1.1 into 25. 3.4. So This is 3.4. Awesome. Now we have a lot to calculate for h, because almost all of them go through h: 25, 6, 7, 29, and there's 30 as well. So let's do those. Let's take a fresh page for h to do its special honor. So big D is 18.75 feet. This is the grid. Big E is 28 feet minus 24.27. .73. Sorry, my bad. This is not 28. I'm reading it wrong. You need to keep these things clean. This was 30.75. So let's redo that. Big E is equal to 30.75 minus 24.27. So 6.48. That's a lot. And we will need to determine e's, but for each. So let's do that, and I'll speed this process up. That is great. We have everything for line H. A very small calculation left. We only need to do for K, for I, for L, and for J. All of these has only one value, so this would be pretty simple. So H, let's do it for I. Our capital D is 18.75. Our capital E is 29.5 minus 28.85. Zero 0.65. Our small e is 29 minus 28.85. 0.15. So for D, E by E into capital D, which is 0.15 divided by 0.68 into 18.75. Let's do it. $4.13. So this is 4.13. Let's do it for this J. D is gonna be the same because this is the same grid. 18.75. E, let's see for E, 30.75 minus 29.95. And small e is 30 feet minus 29.95, 0.05 feet. So D is equal to 0.05, 0.8, 18.75. $1.17. So that is from here to here. 1.17 feet. Awesome. K and L. For K, D is 25 feet. E is 30.75 minus 29.5. And E is 30.75 minus 30, which is 0.75. So d is equal to E by E into D. E is 0.75, capital E 30.75 minus 29.5, 1.25, and this is 25. So 0.75 divided by 1.25 into 25, 15. So this guy is at 15. From here though, not from here, because we're calculating from the smallest. And last but not least is L. I think for L the calculation is going to be the same because all the values are the same. So this is 15 feet. So now we need to draw this into scale. Now that we are done with determining the values of our elevation points, it's time to draw them on scale. So far, what we have done beforehand was just an approximation, as you can see. These elevation look nothing like what it's actually is. So we are trying to put them in scale. So before we do that, it's important that you understand how this works. This is a triangular scale, and here you'll see different types of scales are already written. So the drawing that you have gotten in class is a 1 by 16. There's no 1 by 16, so you might need to do a multiplication of sorts to get actual 1 by 16. But for this demo, I have taken 1 by 8. So here you can see and 1 by 8 over here. So this, in the case of 1 by 8 is 1 foot, 2 feet, 3 feet, 4 feet, and so on. So we have determined the different distance from different points, and we'll put them in place. So let's start with the 25 feet. So from here to somewhere over here, we have 11.13. So let's see if we can find that. So 4, 8, 12. So this is 11. 11.1 would be somewhere over here. So let's try to put that in scale. So 11 is right here. 11.1 would be somewhere over here. So this is 0. So this is our 25 feet. So the next 25 feet is 3.98 in this line. So let's put it over here and try to find the 3 point, which is very close to 4. So 3.98. So that is another 25 feet. And the last one is 2.11, which is right over here. So 1 and 2 and then 2.11. So 25 feet. So this in reality would be our 25 feet contour line, which is quite different from what we determined earlier on, because that was an approximation. This is the scale drawing. So let's do for the 26 feet. 26 feet starts over here at 9.61. So here, and then this is 8 and 9. 9.61 would be somewhere over here. So 26 feet. Then the other one is at 9.44 over here. So 9.44. 9 is here. 9.4 would be somewhere over here. So 26 feet. And 26 also goes to H at 5.1. So H at 5.1. This is 5, so 5.1, very close to 5. So that is another 26. So this is our 26 feet contour. So that is the 26 feet contour line. Beautiful. Now 27 is 4.17 at line B. So 4.17, so 0, that is 0. It's important that you see the 0. So 0 to 4.17. Then it goes here at 1.82. So 1.82 would be close to 2, so that's 27. Then the other 27 is at F at 9.44. So let's see, at F and 9.44. Am I doing it right? No, it's at 14.9. 27 feet is at 14.9, so 12, 13, 14, and very close to 15. So that's another 27, and 27 also goes to H at 7.89. So at H, so 7.89, very close to 8. So that is our 27 feet contour line. So 27. Awesome. Now for the 28, we already have a 28 over here. That would be the starting. Another 28 goes to D at 10.97. So let's try to find the 10.97. So 8, 9, 10.97, very close to 11. 28, another 28 is at F, 20.36. So let's try to find that out. 20.36. I'm over here. And another is at H on 10.79. So H and 10.79, 8, 9, 10.79. Somewhere over here. So that would be our 28 feet contour line. Right? Now for the 29, it's one would be at E 9.62. So this is E and 9.62. Then one would be at G 3.41. G and 3.4. Other would be at H at 13.63. So 12 and 13.63. And that would be our 29 foot contour line. Oh, we missed one. We need one at I, which is 4.13. So 4.13. The contour line looks something like this. All right, made a small mistake there, so let's fix that guy. Yeah, that's our 29 feet. And now for the last one, 30. 30 would be at J at 1.17. So J 1.17. 1 would be on L at 15. 12, 13. This is 15. Another one would also be at L at 15, but this time from here to here. So 15, and let's point out the 0. And one would be at 16.58. 16.58. So that would look maybe something like this. That can't go here because 28 and 29.95, so all of them are above. So this is again an approximation, but yeah, there you go. That's how a scale drawing would look like. Okay, done.